Given the following 6 vectors of R4, we are asked to find a basis for the subspace V spanned by the first 4 vectors, for the subspace W spanned by the last 2 vectors, and then for the subspace V intersected with W. First, note that the subspace V is the column space of the matrix A, whose columns are the vectors U1, U2, U3, and U4. After some elementary row operations, we notice that the pivot columns of A are the columns 1, 2, and 3, which means that the vectors U1, U2, and U3 form a basis for V. Now, it is clear that the vectors U5 and U6 form a basis for W because the set U5, U6 spans W by definition of W, and the set U5, U6 is linearly independent since it's a set of 2 vectors and none of them is a multiple of the other. Now let's find a basis for the subspace V intersected with W. First, let's see what does it mean for a vector U of R4, so let's say of coordinates X, Y, Z, and T, to be in V and W at the same time. So U is in V means that U can be written as a linear combination of the vectors U1, U2, and U3, and U is in W means that U can be written as a linear combination of U5 and U6. In other words, there exist scalars, let's say A, B, C, D, and E, such that U is equal to AU1 plus BU2 plus CU3. This expresses that U belongs to V, and also U equals to DU5 plus EU6, which expresses that U belongs to W. Now, in this vector equation, if we take these 2 terms to the left-hand side, we obtain a linear system in the variables A, B, C, D, and E, whose augmented matrix is the following. Using a row echelon form of this augmented matrix, we solved the previous linear system, and we notice that the basic variables are A, B, C, and D, and the free variable is E. Now, if in this expression of U we replace A with 2E over 3, B with minus E over 3, C with minus E over 3, or if in this expression of U we replace D with minus 2E over 3, so in both cases we find that U is a multiple of this vector 1, negative 2, 3, 1. Note that only one of these steps is enough, and it implies that the vectors of V intersected with W are exactly the multiples of the vector 1, minus 2, 3, 1. In other words, we showed that the subspace V enter W of R4 is spanned by the vector 1, minus 2, 3, 1. And since this is a non-zero vector, it forms a linearly independent set, and therefore it's a basis for the subspace V intersected with W.